Question number 7. Alright, so question number 7 over here asks us, how do you find a range of y is equal to x plus 5 divided by x minus 2? So, keyword here is we want to find the range of this expression. So we have y is equal to x plus 5 divided by x minus 2. So this is the expression, and we try to find the range. So let's go through the Junior Tutor's answer. So what is required is, as we said before, the solution is essentially what you do here is you flip the x's and y's. So wherever there's an x, you put a y, and wherever there's a y, you put an x. And then after you've done this step, you solve for y. So this is what they've done over here, and they end up with the solution. So let's go through this. So we'll switch this up. So we'll have x on the left, and then y plus 5 divided by y minus 2. So we'll multiply both sides by y minus 2. So let's use a different color over here. So times y minus 2, and then times y minus 2. And we end up with, we have x times y minus 2 is equal to y plus 5. And then we just expand this out. So we have xy minus 2x is equal to y plus 5. So here we're trying to isolate for y. So we want to put all of the y terms on the left side. So we'll subtract y from both sides and we'll add 2x. So use a different color. So we'll say minus y over here, minus y on the left side, and plus 2x, and plus 2x. So we're still at the same equation because we're doing the same to the left side and right side. That doesn't change the equation because these just cancel out. We're just trying to eliminate some terms and make sure that the y's are on the left side. So right away we can cancel the 2x's here. And we can cancel out the y here and the y here. Excuse me. So we'll cancel out the y here and the negative y here. And what we end up with, so we know this cancels out, this cancels out, this cancels out, and this cancels out. So we're left with xy minus y is equal to 2x plus 5. And then I'll erase this stuff, make some space. Okay, so we'll move this up here, or I'll put an arrow like this on the side. So we'll factor out the y, so we'll have x minus 1. So we just factor out the y on both terms, and we end up with x minus 1 times y is equal to 2x plus 5, and then y is equal to 2x plus 5. We'll divide by x minus 1 on both sides of the equation, so I'll write that out more clearly. So divided by x minus 1, and divided by x minus 1. So these two cancel out, and we're left with y on the left. And we still have divided by x minus 1. So I'll erase this step. Erase all this. So this is what we end up with. And to find the range, we're really looking at the denominator here. So we know we set the denominator to 0. So we'll say x minus 1 equals 0. And then we solve for x, so we get x is equal to 1. So we know the denominator cannot be equal to 0 because if we have something divided by 0, it'll just be undefined. That's just a general rule for algebra. And then we know that for this function, the range is where x does not equal 1. So just looking at the Janine The Tutor's answer here, we can see that because we're in a situation where x does not equal 1, so they go through the same process, end up with the same answer, our range is negative infinity to 1. My bad. Let me actually write this a little better. So the range is negative infinity up to 1, but not including 1. So usually if you want to include 1, you use a square bracket, but here we're using a non-square bracket. Up to 1 to positive infinity. So mainly based on this. So this right here, when we did the simplification, ended up with this. We know that the range is this because we know x cannot equal 1. Therefore, the function exists everywhere except that 1. So just going through again, just giving a quick summary. The first step is we flip the x and y. So finding the inverse of the function is flipping the x's and y, and then we solve for y. And then we look at the denominator and set that to 0, and then this tells us the range over here of this function, of the original function. So the range of this original function is this down here, and this is our answer. So great job, correct answer. So we'll mark this question as correct and move on to the next question.